We have to spend some time talking about turbocharger diagnostics, and it's a little bit of a complex subject, so let's make sure we verify there are no other concerns that would cause low boost pressure before diagnosing the turbo. Boost is created by the exhaust volume, which is a function of the amount of expanding gases we get from combustion. Anything that will cause low power, low combustion, will create low boost. For instance, defective injectors, EGR, exhaust leaks, fuel pressure problems, fuel quality problems. We need to start our diagnostic by analyzing and verifying the map sensor, the barrel sensor, and exhaust back pressure parameter IDs. They have to be within 1.5 psi of each other, key on, engine off. This is basically our starting point. We're going to use these values for calculating scan data values that we're going to be using in the testing. Now, this is an important step. We're trying to give you tight specifications. The only way tight specifications are going to be effective is if we have a good reference to based back to barometric readings. Let's talk about this. We're going to use bidirectional testing controls of the scan tool to command the VGT control solenoid. We're going to connect a pressure gauge to the intake manifold. This test is only valid if the vehicle has a production exhaust system. We can't guess what it's going to be if you've changed the exhaust system, added turbos, low restriction exhaust, whatever you want to do. We're going to raise the RPM up to about 1200 RPM, and we're going to watch the exhaust pressure sensor. Here's what we're going to do. We're going to command the VGT control solenoid to 85%. Then we're going to command it down to 0. We're looking at the changes in exhaust back pressure. Now, this 7.3 is added to our barrel we started with because the engine running now. We see no change in back pressure. We don't have enough exhaust flow to make much change in backflow. That's what it's telling us. So to see the change, we have to go to the manifold pressure side. We put a pressure gauge in the manifold pressure side, and now we should see readings that vary between 0.45 at 0 up to 0.87. We increase to 85%. These values, remember, are added to our starting point. If we had 14.4, you'd be looking at it going from 14.85 at the 0%. So you get an idea of why we had to be so tight with our map sensor readings, because the barrel readings have to be counted if we're going to make these small differences in pressure have any meaning. So if we do this, accommodate the back pressure with the key on engine values, you have a valid test. Now, here's what happens. If the values are within range and the computer in the compressor isn't noisy, with the blades striking something, and you can get these blades to strike by running the duty cycle up and down. You do not replace the turbocharger. They changed. That's what we expect to happen. But if they do not move and they're not within range, then we're going to continue the next test. We're going to raise the RPM to 3,500 and hold it steady. We're going to be getting some turbo boost here. Now we're going to see exhaust back pressure between 2 and 6 psi and manifold between 5 and 13 psi. So now that we've done this, we're going to see we've made sure that it worked, and we've gone in and done something. If both are high, disconnect the VGT control solenoid and repeat the test. If the values change with the VGT disconnected, inspect the wiring harness and connections, because it should be changing. When we disconnected it and caused the VGT to change, it changed values. With the VGT controller, remove the valve from the turbo, being careful to handle the valve by the solenoid body only and not get your fingers down on the valve. Plug it back into the wiring harness so we can make it work. We're going to use the bidirectional controls on the scan tool to command the movement of the actuator. And we're going to use our finger with it on the cam follower to check for light pressure and see if we can detect movement. So here's our VGT control. We're going to remove it from the housing. We're going to put our finger on the cam follower and see if we can detect movement. The valve should be free to move. So what we're going to do now is we're going to take the VGT control duty cycle with our scan tool and vary it up and down and see if we can feel any movement. If we can't feel any movement, we're going to have to go beyond that. The cam follower is at the end of the valve assembly, and it provides feedback to the valve, allowing it to reach a park position during times when the vane should be commanded to not move. So this is going to let us know where we are. It should be able to push inward and move easily. And since we've moved it here and we see it's free, we know it's not sticking. So if we didn't get any movement, it isn't because this is sticking. We need to go look at the electrical side. If it didn't move, there must be something wrong electrically. Starting first of all, we can use ohm meters. We can, at 73 degrees, we should have 3.42 to 4.18 ohms. If it's hot, I don't know why you're holding it, but it should be 4.4 to 5.3 if you want to test it with the engine oil temperature high. That's part of the picture. The other part of the picture is we've got to get power and duty cycle control. This is our duty cycle control on pin 1. We have battery voltage coming to pin 2, and we're going to supply ground to energize the actuator. So with the key on, engine off, we should see battery voltage with 0% duty cycle. As we start the vehicle up and get it running, we will see this voltage starts varying as it's varying the duty cycle. If you have any problems with this, you need to get good B+, you need to get ground working. If you don't get these, you need to go back and diagnose the wiring and the electrical system to find out why.